Okay, quickly. There should be 48 students. Okay. So according to my attendance, there should be 48. Okay. So we will start now. So what is IA? Okay. So this is IA. What is IA? Quickly, 3 seconds, 2 seconds, 1 second. Okay. So most of you still cannot answer it. So if you look here, this is, okay, this is super node. Okay. So basically V1 automatically equals to V1 equals to 30 because there is no resistance here. Okay, there is no resistance. So the voltage here automatically become 30 volt. Okay. So 30 volt divided by 3 equals to 10. Okay. So the answer is 10. So goes to the next question. Okay. Harry get the highest mark right now. Okay. Okay. Nodal expression again. Express the IC. What is IC? What is the expression of IC? $15 seconds. 10 seconds. 5 seconds. Okay. So only 9 of you get the answer. Okay, if you look here, this is V5. Okay, this is IC. Okay, so IC, remember the formula how to get it? So from where to where, divide by resistance. Okay, and if there is a voltage source, don't forget to plus or minus it. Okay, if the current goes into minus, it will get plus. So how to do this? Okay, so if you look here, it's the IC current is from, so the IC current is from, okay, point here, plus minus point here, V5 and V4. So I see the direction is here. So remember the formula. So for nodal analysis, for the current V5, okay, start from where? Minus to where? V4, okay, from V5 to V4. Then the current goes into negative, okay, Vs2, okay, goes into negative, so become positive. Vs2 divided by R3. Okay, this one is R3. So that is how you get the answer. Okay. Now we look who's the highest score. Okay. Still Eddie. So we go on to the next question. Write the final expression of this using nodal analysis. Okay, you have 4 minutes for this question. So you can take your time. Okay, somebody already give the answer. Okay. So write the final expression. Means that you have to simplify it to the standard form. Okay. So you have 3 more minutes. You can still join the session. Just enter this pin below. Okay, 2 more minutes. Okay, 1 more minute. Thirty seconds. Ten seconds. So time's up. So okay, basically only 1/3 of you can answer this. Okay, how to do this? Okay, first you look at V1. Apply KCL at V1. Okay. KCL at V1. Okay, so when you apply KCL at V1, okay, you can choose either assign branch current or use all current goes out of the node. So for this case, I assign all current go out of the node. So V1 minus 0 divide by 3. Okay, for the first current, okay, for the first one, okay, the first branch to the left, and then the second branch to the to down is plus, okay, V1 minus 0, okay, because from V1 to 0 to ground, okay, because it has voltage source and it's enter positive, so minus 12. Okay, if enter positive, you have to invert it. So divide by 6. Okay. Then lastly, okay, the branch that goes to the right, okay, plus V1 minus V2 divided by 12 equals to 0. So you can simplify this. Okay, this one multiplied by 4. Okay, 4 V1 plus this one multiplied by 2. 2V1 minus 24. Okay, then plus V1 plus minus V2 equals to 0. Okay, if you have any question or I write it wrong, so please tell me using your mic. Okay, so now you rearrange again. 4, 2, 6, 7, V1. Okay, minus V2 equals to 24. So you get the first expression. Okay, if you look here, okay, you add the answer below. Okay, a left side, lower side. Okay, okay, you get the first answer. Then after you get the first node, you apply KCL at second node. KCL at V2. So again, go look at the node from to the right, from left to the right, from right to the left. Okay, so V2 minus V1 divided by 12. Then plus, okay. So because this is the opposite side of the outside the node, okay, if you look at the node, we assign all goes to outside. So but for this case, it goes inside. So just put negative 1. Okay. And then lastly, plus V2 divided by 24 ohm. So the V2 to left. Okay. So equals to 0. Then rearrange this. Okay, this one multiplied by 2 minus 2V1 minus 24 plus V2 equals to 0. So after this, negative. So negative 2V1, okay, minus or plus 3V2 equals to 24. So you get the second answer. Okay, make sure you know how to do this. Okay. So look who has the highest mark right now. So Nini has the highest mark. So we go on to the next question. Using all current out of the node method, apply KCL at V1. Okay. So try to apply KCL at V1. So this one is V1. Okay. Okay, if you use assign method, assign branch current method, you still get the same answer. Okay. So 20 more seconds. Five more seconds. Okay. Still, many of you still cannot answer this. Okay, how to do this? Okay. So you apply KCL. Okay, apply KCL at V1. Okay. So first, because it goes into the node, so negative 5. Then plus the branch current at 6 ohm. Okay. V1 divide minus 0. Okay. Then this one enter positive, so negative 7. Okay, divide by 6. Okay. And lastly, the last branch is plus V1 minus V2. Okay, because the current enter negative, so should be plus 5. Okay, divide by 3. So the answer is, okay, wait, equals to 0. Okay. So, okay, you get the expression. So if you look at the answer, okay, you get the expression. Okay, we look at the highest mark. So I don't know how to say this. Okay. So you get the highest mark. So we move on to the next question. Okay, using all current out of the node method, find the KCL, apply KCL at V2 for nodal analysis. Okay, same as before, but this time at V2. You have 90 seconds. Okay, 15 more seconds. Okay. 1/4 of you get the answer right. Around 1/4. Okay. So how to do this? So if you look here, so apply KCL at V2. Okay. So you look the 3 ohm. Okay. Look at the 3 ohm. Apply V2 minus V1. So the current goes into positive. So minus 5. Divide by 3. Then plus. Okay. Look at 12 ohms. So V2 minus 0 divide by 12. And look at 24 ohms. Okay. So for 24 ohms, okay, you don't need to write it because you have current source. So automatically just use the current source. Okay, no need to write the expression voltage or voltage expression because the currents it is current source. Even it has resistance, you just ignore the resistance. Okay. So if you look here, If you look, the answer is okay. Okay, it's the same. Okay, now we look at the highest mark. Okay. Okay, Y, JS. Okay, you get the highest mark. Okay, we move on to the next question. After nodal analysis, V1 and V2 is obtained. So find IA. So what is IA? Still nodal analysis. Okay. 40 more seconds. $20. 10 more seconds. Okay. Most of you still cannot answer this. Okay. So how to do this? Okay, what is IA? So IA is, okay, basically use the formula, okay, from where to where? Okay, from node V1 to node, okay, minus to node V2. So because the currents enter positive, so minus 30. Okay. So divide by 30. Okay. Divide by 20. So IA again, V1 is 50 minus 100 minus 30 divided by 20. So negative 50 minus 30, 50, 30, 80 divided by 20, you get negative 4. So the answer is negative 4. Okay. So be careful, positive and negative has meaning. Okay. So the highest mark, okay, still JS. Okay. Now we move on to the next question. Okay, what is loop current? Okay, you have 20 seconds. Okay, what is loop current I1? Okay, 10 more seconds. Okay, this is I1. 5 more seconds. Okay, most of you get the correct answer. If you look here, this is super mesh. Okay. Okay, because the super mesh is opposite side of the I1 loop current. Okay. So you have to put negative 3 ampere. Okay, that's it. So make sure you know how to detect super mesh and super node. Okay, look at the highest mark right now. Okay, YYYJS. Okay. Okay, next question. What is IA? So what is IA? You have 15 more seconds. Okay, most of you get correct answer. Okay. So if you look here, okay, if you look here, this one is also considered as super mesh. Okay. So if you look here, IA is basically equals to the current source. Okay, the same one. Okay. So we look at the highest mark right now. Okay, Lukman has the highest score. So we move on to the next question. Apply KVL at IB. So IB, apply KVL. You have 20 more seconds. 10 more seconds. So time's up. So okay, most of you still cannot answer this. Okay, if you look here, okay, if you look at IB, okay, so we start with 4 ohms, okay. So remember, when involve resistance, it automatically positive. Okay, so 4. Okay, 4 ohms plus, okay, 4 IB, because we apply KVL at IB, so you have to write IB first, then minus IA because it intersect with the opposite loop. Okay, then okay, it meet negative, it meet 5 volt. Okay, for this nodal, for mesh analysis, you just follow it. Okay, if the currents enter negative, you just write negative. Okay, for nodal, if current enter negative, you have to write positive, so invert. But for mesh, you have to write what you see. Okay, and then lastly, at the 8 ohm, so plus 8 ohm, there is no current, other current, so just IB equals to 0. So if you look here, so this is the answer. 4 IB minus, okay, 4 minus IA minus 5 plus 8 IB. And remember that previous question, this one is 3, okay, super mesh. So you just write, okay, 4 IB minus 3, okay, minus 5 plus 8 IB equals to 0. Okay, so we see who's the highest score right now. Okay, still Lokman. Okay, we move on to the next question. Okay, apply KVL at IC, the same circuit. Okay, you have 20 seconds. This one is much more simple. Okay, 5 more seconds. Okay, most of you get the answer. So this one is simple. So apply KCL here. So if you look here, the current IC enter 5. So enter positive part, so just 5. Then plus 16. Okay, the current is IC, don't have any intersection, just put IC. Equals to 0. That's it. Okay. So and we move on to last question. Okay, the highest score, Lukman. Okay. So move on to the last question. Okay, after mesh analysis, loop current is obtained. Find V, okay, find VV1 and VR2. Okay, you have 15 more seconds. 50 seconds. Okay. Twenty more seconds. 5 more seconds. Okay. Okay, only 1/3 of you, 1/4 of you get the correct answer. Okay. So how to do this? Find VR1 and VR2. So VR1 is located here. Okay, at the top. VR2 located at the bottom. So we look at VR1 first. So VR1 is, so you have to find the current first. So IA equals to, okay, IA equals to negative I1 equals to negative 1 ampere. Okay. So R1 equals to, so negative IA multiplied by R1. Okay, negative because remember the law is if you want to calculate the voltage for the resistor, you have to, the current needs to meet positive. And if the current doesn't meet the positive side, you have to put negative. Okay. So negative 1, 8, you get 8. Sorry. 8 volt. So is it correct? Okay. Is there any mistake here? So the answer should be negative 6 volt, right? I think I write the answer flip. Yes, it's flip. So the answer should be 8 volt. Okay. For the second one, okay. So what is IB? So IB equals to, okay, you have to look at the current that's follow IB, which is I3 minus I1. So 3 minus 1 equals to 2 ampere. So VR2 equals to, okay, if you look here, VR2. So the current IB enters positive side, so no need to put negative. So just IB R2, you get 2 multiplied by 3 equals to 6 volt. Okay, so the answer is flip. Okay, I will correct it that later. Okay, we have finished our question. So we look at the highest. Okay, highest score. Okay, the third place is Frida. Second place is Eri. And the highest score is, okay, Lukman. Congratulations. Okay. Okay, that's it. Okay, for those who still doesn't take the attendance, please do so. Okay, if you have any question, you can open your mic. Okay, we finished the class. Okay, you can leave the classroom. Thank you.
Thank you, Doctor.
You are welcome.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Okay, you are welcome.